Origin announces which booster will be flying on New Glenn's third flight and shows off its plans for a satellite megaconstellation. Neutron's Stage 1 tank goes pop because of water? Vast delays its space station, and Orbex isn't doing so well. As always, we've got all that and more coming up this week in Spaceflight. Blue Origin is joining the bandwagon of satellite megaconstellations with its own satellite internet services called TeraWave. Unlike other similar megaconstellations, this one is unique for two reasons. The first is because, ironically, the owner of Blue Origin, Jeff Bezos, already owns another company also planning to build its own megaconstellation. I'm referring, of course, to Amazon's Leo constellation, which already has nearly 200 satellites in orbit, but no active service yet. That said, despite both companies being owned in part by the same person, these are two different constellations under two different companies. In fact, the second uniqueness of TeraWave is what makes it stand out from any other satellite internet service, even SpaceX's Starlink. With TeraWave, Blue Origin is promising data transfer speeds that are much higher than any other provider. The constellation would be split into two regimes. 128 satellites would be placed in medium Earth orbit, and 5,280 satellites would be placed in low Earth orbit. The satellites in Leo would be split into three different shells at different altitudes and orbital inclinations, and they would talk to users on the ground through regular radio waves. Meanwhile, the satellites in MEO would be in 5 different shells, but these would be fitted with optical user links, that is, a laser system, to communicate directly to the users on the ground rather than using radio frequencies. Now, you might hear about these laser connections and think, well, Starlink already does that. But no. What Starlink does, and some other constellations too, is use laser links between the satellites to bounce the signals around the globe without having to bounce down to ground stations before reaching a user. And by the way, TeraWave will still use this inter-satellite laser connection. It's just that it would also include this extra option to connect directly to users on the ground through optical communication. Optical communication offers a substantially higher bandwidth, and it works amazingly for communications between satellites, as demonstrated by Starlink. It's a technology that provides data transfers of hundreds, if not thousands, of gigabits per second, and in the case of TeraWave, Blue says that it could provide up to 6 terabits per second with these optical user links. Now, there are a few caveats here worth mentioning, and I'm sure a lot of people have already run into the comments to point these out. First and foremost, no. Starlink is not being killed by TeraWave. While Starlink is mainly aimed at regular users and some industries, TeraWave is aimed at service enterprises, government users, and even data centers, as they themselves point out in their press release. And it sort of makes sense if you think about it. It's highly unlikely that a regular user will need a 6 terabit per second connection, even if some of you may really want a faster connection. But trust me, you don't need it to be that fast. But, for example, with this whole boom of putting data centers in space today, imagine if you could have those satellite data centers with laser links talking to TeraWave satellites, and then those TeraWave satellites sending that data down to Earth at incredibly high speeds, and vice versa. And add to that, you also have the cost and the maintenance of the equipment for the laser connection and whatnot, and, well, it really isn't the best to market this for regular users when you think about it. But there's also another problem with this, and it's that using optical communications through Earth's atmosphere is quite complicated. It's not impossible, but there are a number of challenges that come with it. In space, it's relatively easy in comparison. You just gotta aim in the right direction, and the laser beam goes in that direction. But you can't really say that when the laser beam goes through the atmosphere, because differences in density and temperature and even humidity when closer to the ground can bend the beam and make it point the wrong way. Not to mention that things like clouds would either attenuate or even completely absorb the laser unless it's a very powerful one. This means that it's probably not going to be an all-weather application, but that's when the LEO shells come into play. If you remember from just a couple minutes ago, I mentioned that those use regular radio waves to talk to users. So in this case, these satellites would use Q-band and V-band frequencies for such communications. Despite still using radio frequencies, Blue says that this will still be able to provide up to 144 gigabits per second of connectivity to the users on the ground. To compare that to other internet satellite providers, Starlink offers what they call community gateways, which they advertise as being capable of providing up to 20 gigabits connectivity. So that means more than 6 times higher speeds for TeraWave compared to Starlink's community gateways. What this means is that we're probably about to see some sort of reaction from SpaceX themselves when it comes to the services that they provide with Starlink. Elon has already given some information that we didn't have before, which is that they too plan to have Starlink space-to-ground lasers, and he even claimed that they'll exceed TeraWave's data speeds. SpaceX has the advantage of already having thousands of satellites in orbit, and they keep launching more every week. According to Blue, TeraWave isn't planned for launch until the fourth quarter of 2027, and may very likely delay into 2028. So this means that we could see SpaceX upping their game, especially if they're more successful with Starship this year than in 2025, and they're able to start deploying the larger Starlink version 3 satellites. In other words, Blue's announcement this week could lead to other providers rethinking their focus and improving future plans for their services. Now, interestingly, this ties well with the other Blue Origin story of the week, which is that we finally know what's going to be launched on New Glenn's next flight. This week, Blue Origin announced that the third launch of New Glenn will be carrying a Bluebird Block 2 satellite from AST Space Mobile. AST is working on deploying its own cellular broadband network in space, which will serve users on the ground without the need to modify phones. So yes, that means it's another satellite constellation in space. It just provides direct-to-cell connectivity rather than regular internet services. What's even more interesting about this third launch of New Glenn is that Blue says it's set to fly using the booster from New Glenn's previous launch called Never Tell Me the Odds. The mission, currently set for no earlier than late February, would therefore lead to a booster turnaround of at least 100 days, or about 3.5 months between missions. Not bad for being the first New Glenn booster reuse. Rocket Lab seems to have experienced an issue with its Neutron program involving the destruction of a Stage 1 tank. The company's been working on its big rocket for several years now, and was finally getting all of the parts together ahead of its upcoming first flight. Neutron will be a medium-lift, reusable launch vehicle powered by methane and liquid oxygen. In true Rocket Lab fashion, both stages are manufactured from carbon composites, but unique to this rocket is that the payload fairings are integrated onto the first stage, aiding in their reusability. The first set of these fairings has been making its way from Rocket Lab's facility in New Zealand and are due to arrive at Wallops Island in Virginia, where the company will integrate the rocket ahead of launch from the nearby Mid-Atlantic Regional Spaceport. Last week, the company also shared some pictures of Neutron's thrust structure as it underwent testing at Rocket Lab's location in Middle River, Maryland. This structure houses the 9 Archimedes engines that power the first stage and transfers their loads to the rest of the rocket. At the same facility, engineers had been working on a first stage tank, and Rocket Lab seemed to be getting ready to test this carbon composite rocket part. But this week, NSF's own Patrick O'Loughlin saw that the structure had collapsed overnight. All that was left of the massive carbon composite tank was a pile of pieces in terrible-looking condition. Whatever happened, it didn't look intentional. And it wasn't, as Rocket Lab later confirmed in an official update. The company had been testing the tank as part of its Stage 1 qualification testing campaign, and a so-called hydrostatic pressure trial led to the tank's demise. During such a test, the tank is filled with water and then pressurized to determine whether it can hold up to a certain load. When the structure passes the test, the next step is often to load it with cryogenic liquids and see how it holds up when pressurized under those frigid conditions. But clearly, this tank didn't get that far. Now, that doesn't necessarily mean bad news. As Rocket Lab points out in its update, rocket parts are often tested to their limits to ensure that all safety margins are met. In fact, the company shared footage of Neutron's second stage being tested to destruction in late 2023. That test didn't use water, but liquid nitrogen. However, reading between the lines of the company's statement, it seems that they might not have intended to destroy a tank during this week's test. Fortunately, it didn't lead to any significant damage to the test stand and the surrounding facilities. We don't yet know how this failure will impact Neutron's schedule. Rocket Lab's engineers are studying the situation, and the company promised an update during its next earnings call in February. Fortunately, the next Stage 1 tank is in production, so the failure's impact might not be too big, but if it turns out that there's something fundamentally wrong with the tank design, it could push Neutron's first flight back by quite some time. Let's hope that that won't be the case. Now, if you're thinking we're biased and we're only covering Rocket Lab's failures, well, it seems that this might not be the only test tank that failed recently. Over at Starbase, SpaceX has been preparing its B-18.3 test tank for a series of tests, and it might have experienced an anomaly during one of those tests this week too. We've got a whole show dedicated to the Starship program though, so we'll cover that anomaly in detail on the next Starship update episode. If you want to get notified when we release that episode, subscribe to our channel and enable your notifications. And if you think that YouTube should show our spaceflight updates to more space fans, give us a like and tell your friends about us too. Vast's Haven 1 space station won't be launching this year. The company released an update about the program, including its revised timeline to launch early next year. Haven 1 is the first in Vast's line of space stations, and it's supposed to be a simple, single-module space station to verify the company's designs and get some experience with space station operations. This will help to prepare them for Haven 2, Vast's proposed commercial successor to the aging International Space Station. Ultimately, the firm intends to build an even larger station, which rotates to provide artificial gravity. For now, they're still working hard towards the first step of this dream, Haven 1. Just last year, Vast completed and tested the station's primary structure, which they'd already done once before with a qualification article to verify the design and production processes. With this new structure that will actually be going up into space now completed and pressure tested, the company is ready to start integrating and outfitting the station. This includes the installation of life support systems, fluid systems, and propulsion systems. Following further tests, Vast will then move on to installing avionics, guidance, navigation, and control systems. Finally, they'll outfit the interior to make it comfortable for astronauts, as well as install solar panels, thermal radiators, and shielding to protect Haven 1 from micrometeoroids and orbital debris. So far, Vast has been moving at an impressive pace, but it still hasn't been enough to meet their original timelines. When the company first announced Haven 1, it was supposed to launch in 2025, but that was later revised to May of 2026. This week, they pushed it even further, with liftoff atop the Falcon 9 now planned for the first quarter of 2027. The latest slip in the schedule isn't terribly surprising, though. In early November, Vast launched its Haven demo spacecraft aboard SpaceX's Bandwagon 4 rideshare mission. The satellite's purpose was to test Haven 1's propulsion and avionics systems in space, and while the mission went very well, it was also delayed. When NSF toured Vast's factory near the end of 2024, CEO Max Hout said that Haven demo would be launched on Bandwagon 3, which flew in April 2025.
So Haven Demo is a 500 kilogram satellite that's flying on Bandwagon 3 next year on the SpaceX rideshare, and it's designed to test all of our propulsion, avionics, RF systems,
all the subsystems for
nothing crewed, so no pressurized element to there.
With such an important test mission delayed by over half a year, the newly announced delays to Haven 1 aren't particularly shocking. Reading between the lines of this latest update, Vast appears to blame the delays on just being new to the process. After all, the US hasn't produced a space station module in a couple of decades. The company expects to get better at meeting its schedules for future stations, and honestly, it's an interesting future to look forward to, with them churning out space stations as new destinations for science, exploration, and perhaps even recreation. Alas, for now, that future has been delayed by several months, but we'll certainly keep paying attention to Vast's progress. Now we'll take a look at some other stories across space, starting with some European rocket companies. We love to see rocket engines fire. And this week, Spanish rocket manufacturer PLD Space delivered. The company's working on its upcoming Miura 5 rocket, which will be powered by PLD's homegrown TEPRL-C engine. Miura 5's first stage will be fitted with 5 of these, which guzzle liquid oxygen and RP1, or rocket-grade kerosene, to get going. The company plans to incorporate reusability in a future iteration of the rocket, which involves a soft touchdown under engine power, much like Falcon 9 and New Glenn. This week, PLD announced that it started a test campaign to verify that TEPRL-C has the throttle capability necessary to support first-stage re-entry. Firing the engines upon re-entry helps to control the rocket throughout this challenging phase of flight, and, counterintuitively, the fiery engine exhaust also helps to protect the booster from the plasma generated as the rocket dives into the atmosphere. PLD plans to implement the technology for reusability step by step during the upcoming Miura 5 flights. So we can't help but wonder, how's Miura 5 coming along? Well, in November, PLD showed off the first completed full-size qualification model and promised a second by the end of the year. We haven't heard anything since, though, so it would be great if we could have a little bit more news about that. Either way, PLD plans to complete the first flight rocket soon and launch it this year, so we hope that everything is progressing smoothly. The future seems uncertain for Scottish rocket company Orbex. The company, founded in 2015, is working on a small rocket called Prime. Standing 19 meters tall, this rocket is designed to lift up to 200 kilograms into orbit. With its ultralight structures, it's supposed to be very efficient and have low carbon emissions, for a rocket at least, by using biopropane as fuel. With Prime, the company is participating in ESA's European Launcher Challenge. They'd been trying to launch the rocket's maiden flight late last year, but later rescheduled the mission to this year. But will it happen? Well, this week we learned that Orbex is negotiating to sell the business to the exploration company, reportedly as a result of the company's not-so-ideal financial position. Shortly after the news broke, European Spaceflight reported that Orbex's Danish subsidiary is closing up shop and about to file bankruptcy. Well, that doesn't sound great, does it? Orbex used its Denmark facilities for engine production, among other things, and losing that doesn't make rocket production any easier. Could the exploration company right the ship after taking over the business? The company, founded by former Airbus and Ariane Group engineers, has managed to rake up contracts for all sorts of projects, but the exploration company has no experience building rockets. Instead, their main focus is the Nix cargo capsule, which they designed to resupply the ISS and other future space stations. This week they showed off their progress on Nix's structural test model. In addition to capsules, they're also working on engines. First, they've got spacecraft thrusters called Mistral. They're also working on a methane-powered engine called Huracan, which is supposed to boost Nix's lunar variant. Finally, there's Typhoon, a Raptor-sized, full-flow staged combustion cycle reusable rocket engine. All in all, it seems that the exploration company has the knowledge required to help Orbex now that its engine manufacturer is in danger, and adding a rocket to their lineup doesn't seem like a bad idea either. We'll have to see whether the companies can work out terms for a takeover, but hopefully this won't be the last that we hear of the Scottish rocket. The Japan Aerospace Exploration Agency, or JAXA, has been investigating the failed launch of its H3 rocket back in December. They've now announced the initial results, and it turns out this is one of the strangest rocket failures that we've seen. So what happened? On December 22nd, the H3 rocket lifted off from the Tanegashima Space Center to launch the Michibiki 5 satellite. Initially, all seemed normal, but the second stage's first burn took longer than expected, and that same stage failed to ignite for its second burn. It never made it to its intended geostationary transfer orbit and was believed to have gotten stuck in low Earth orbit instead. But as it turns out, the satellite may not have even gotten that far. After carefully analyzing images from onboard cameras, JAXA concluded that the carbon composite payload adapter broke during the first stage flight. As a result, the satellite can be seen shifting position in the onboard images, and there's a lot of debris visible too. Then staging happened, and during that time, the rocket and its payload experienced zero-G for a moment. The broken payload adapter meant that the satellite was no longer attached, and it separated from the rocket. The damaged second stage then ignited and tried to get as far as it could. This is truly an unusual rocket failure. We've seen a lot, from engine issues to fairings refusing to separate, but the front falling off? That's not very typical. The rocket that will carry humans around the moon for the first time in over half a century has made its way to the launch pad. NASA rolled out the SLS for Artemis II on January 17th. It wasn't a speedy process, though, as it took nearly 12 hours to reach the pad after the rocket left the vehicle assembly building at the Kennedy Space Center. The rocket made the 4.2-mile journey, or roughly 6.6 kilometers, to Launch Complex 39B on top of the crawler transporter, which not only carried the SLS itself, but also its launch mount and launch tower. Once in location, teams began to hook up lines and prepare the rocket for its wet dress rehearsal, which is planned for later this month. During this test, NASA will fully load the rocket and go through the countdown procedure, stopping only a few seconds before liftoff to ensure that the rocket and its pad are ready for the big day. If all goes well, the launch window will open on February 6th, but NASA also has the option to roll SLS back to the VAB if more work is needed. Of course, the stars of the Artemis II mission will be the 4 humans flying in the Orion capsule: NASA astronauts Reed Wiseman, Victor Glover, and Christina Cook, and Canadian Space Agency astronaut Jeremy Hansen. But they won't be traveling alone. This week, NASA announced that they'll be taking a set of keepsakes with them around our celestial companion. It's a surprisingly long list, which also includes a few items from NASA's international partners. But let's take a look at a few highlights. First, there's a small piece of fabric from the original Wright Flyer, the first vehicle to perform powered flight. There's also a small US flag, which also flew on the very first space shuttle mission, STS-1. That same flag was then brought up to the ISS by the final shuttle mission, STS-135, from where it was retrieved by NASA astronauts Doug Hurley and Bob Behnken during the SpaceX Demo 2 mission. Artemis II will also bring along a flag that was slated to fly on Apollo 18 before that mission was canceled. Although it never got anywhere, this small relic of that flight will finally make it close to the moon and show that we're finally going back at last. This is your weekly space traffic report provided by Next Spaceflight. This past week was really not a great week to be a Chinese rocket, as we had 2 back-to-back failures from different rockets out of the country. The first failure came from the launch of a Changzheng 3BE rocket out of Xichang, which was carrying a secretive experimental satellite for the Chinese government. During ascent, the rocket's third stage failed, and neither the rocket nor the satellite reached orbit. The third stage of the Changzheng 3BE is a relatively small, hydrogen-fueled upper stage that shares commonalities with the Hydrolox upper stages of other similarly sized rockets in China. So, as a result of this failure, some other launches have also been paused for the moment. This failure also coincided with the start of a roughly 1-month-long series of celebrations ahead of the Chinese New Year, a period that also sees a reduction in launch activity from China. So with all that said, don't be surprised if we don't see a ton of launches from them in the next month or so. Now, when it comes to launch failures, this one was a rather weird one, because the Changzheng 3BE is a relatively old rocket with a rather decent track record. That said, it's not much of a surprise when a launch failure happens to a brand new rocket, and that's exactly what happened to the other Chinese rocket that failed this week, the Series 2. Series 2 is a larger sibling of Galactic Energy's Series 1, with 3 solid rocket stages, plus a 4th hypergolic stage used for orbital insertion. Essentially, an almost identical copy, but with a much wider diameter. According to reports from local spectators, the rocket started having problems shortly after liftoff, then crashed to the ground. No details have been published about the accident, and little to no pictures exist of the rocket or its failure. We did have at least one successful launch from China, with the Changzheng 12 launching another batch of Guowang Internet satellites. This week, we also had the successful return of the Shenzhou 20 spacecraft. This is the spacecraft that was found to have a crack in one of its windows in early November and was deemed unsafe to return its crew back to Earth. Well, after staying for a little longer at the Tiangong space station, it returned, uncrewed, this past week. While it didn't carry anyone on board, it did carry some cargo back to Earth, and the damaged window was quickly covered up after landing. The reason for this was supposedly to preserve the state of the window for later analysis. It's not clear whether we'll ever get any information as to what happened to it, as well as what happened to the capsule during descent because of it, but here's hoping that we do. This week, we also had 3 Falcon 9 launches by SpaceX, 2 of them from Vandenberg and 1 from Florida, and all 3 carried pretty much the same kind of payload, more or less. 2 carried batches of Starlink satellites, while the other carried a batch of Star Shield satellites. Rocket Lab also had its first launch of the year, with Electron's launch of the Cosmos Will See You Now. The mission was carrying the first 2 satellites of Open Cosmos' broadband constellation, and marked the 80th flight of Electron overall. Finally, in the realm of suborbital launches, we had Blue Origin's New Shepard rocket carrying another 6 passengers to the edge of space and back. This mission was notable because one of the original passengers, Andrew Yaffe, became ill and had to be replaced by Laura Stiles, who works at Blue Origin as director of New Shepard launch operations. This means that, for the first time in her 13 years working on the program, she got the chance to actually experience the whole thing. Congrats! Going into next week, we'll have up to 4 Falcon 9 launches, 3 of them carrying batches of Starlink satellites, and the 4th launching the 9th GPS-3 satellite for the US Space Force. Rocket Lab is also looking at launching another Electron from New Zealand with the Bridging the Swarm mission. And we may also potentially have 1 launch from China out of Wenchang. Up in orbit, we've also got the unberthing and release of the HTV-X1 spacecraft, which will depart the ISS after 3 months. After separation, it'll remain in orbit for a few more months to carry out further missions while in free flight and demonstrate longer on-orbit durations. As always, we recommend that you visit nextspaceflight.com or download the app on your phone so you can be up to date with these events whenever and wherever you are. And that's your weekly update of spaceflight news. I'm Alicia Siegel for NSF, and we'll see you all again next week to recap this week in spaceflight.